In this video, we're going to take a look at another example where we test a claim about a mean. So here, let's go through and read this. The weights of discarded plastics from a sample of households has summary statistics n equals 62, x bar is this, and s is this. Now at this point in time, you might say, I think we already watched a video about this. Here's a new sentence that's going to make this problem subtly different. Previous research suggests that the standard deviation among the weight of discarded plastics from all households is also 1.065. Use a 0.05 significance level to test the claim that the mean weight, so we're testing the claim that the mean is greater than 1.800. So our claim is the mean is more than 1.800. The opposite of the claim is no, it's not. It's not more than 1.800. It's actually less than or equal to that value. From these, we identify the null and alternative hypothesis. So our null hypothesis is the mean is equal to 1.800, and the alternative is that it is greater than 1.800. So that alternative hypothesis, we identify it is the one of these two things that does not include equals, so in particular, it is coming from the claim. The alternative hypothesis is the claim. All right, so we have our null, our alternative hypothesis. Our significance level that we're going to use is 0.05. Because our alternative hypothesis has a greater than sign, if we were to look at what our graph is going to look like, it is a one-tailed test. Because of the greater than sign, that one-tailed test should be on the right. And so this one-tailed test on the right, the area here is that significance level, 0.05. Then the other values that we are given in this problem is a sample size n is 62, sample mean x bar 1.911, s sample standard deviation is 1.065. And then they also tell us that the standard deviation among all households, so that is sigma, is also 1.065. All right, so we're going to take those things and we're going to go to StatDisk with those. So here in StatDisk, going to choose analysis. We are doing a hypothesis test, so I choose hypothesis testing, and it is a hypothesis test about a mean. So mean, one sample. Our alternative hypothesis is that the population mean is actually greater than 1.800, so its population mean is greater than a claimed value. Our significance level is 0.05. The claimed mean, that comes from our null hypothesis. And so the null hypothesis is that the mean is equal to 1.800. Population standard deviation, we do have this here. It was 1.065. When we did this in an earlier video, we did not have the value of the population standard deviation, so we left that blank. 62 was our sample size. 1.911 was our sample mean, and our sample standard deviation here, 1.065, that was also given to us. Even if I didn't have that, it really doesn't matter what value I put in there. Because we have the information about the population standard deviation, it's going to take precedence. So we evaluate this, and we see a p-value is 0.2059. we compare that p-value to the significance level. If the p-value is high, the null will fly, so we fail to reject the null hypothesis. So what has happened here is we have this p-value of 0.2059. So somewhere up here, there is this area of 0.2059 to the right of this test statistic that we would have calculated. So the area, that area is more than the area in that tail, that region of rejection, so we fail to reject the null. We are not in the region of rejection. Next up, we have a critical value method. So for our critical value method, we look at our critical value. So we just have the one critical value, 1.645. So 1.645 is our critical value. And it was a z-value. Our test statistic was also a z-value, and it was I didn't observe it fully, but it was 0.821. So 0.821 is our test statistic. So what that tells us here is right there is our test statistic, 0.821. So that is the location, so not the area. The value right here is our critical value. That is the 1.645. And so since this value here does not occur in that region of rejection, we fail to reject the null. And then finally, our confidence interval method. With that, if we go back to StatDisk one more time, down here at the bottom, we have 1.689 to 2.133, 1.689 to 2.133. So that is the confidence interval associated with this sample here in purple. That confidence interval associated with that sample there in purple, it does in fact contain the null hypothesized mean. So 1.800, that null hypothesized mean, is in the confidence interval. So we fail to reject the null. All right, that is it for dealing with hypothesis tests, dealing with means. Next time we'll look at hypothesis tests for standard deviations.